Hi friends, today I am going to discuss about a new method in the geometrical optics that is called matrix method. Matrix method. Matrix method. It is a special kind of method used in geometrical optics. Geometrical optics for representing the position of or the properties of an image formed by a light ray when it propagates through a medium. Normally, when a light ray propagates through a medium having refractive index value mu, then for such a propagation, the normal method used to represent this light ray is that this medium is divided as large number of refracting surfaces, and through each of these refracting surface we are doing a step-by-step process to find the final image formed in a medium. This is the source of this light ray. This method used here is nothing but that we are considering a first refracting surface, and we are obtaining an image formed by this refracting surface is something like this one, image formed in this point, and we are considering this image as the object of this second refracting surface, and due to this object for this second refracting surface, an image is formed somewhere beyond this second refracting surface as someone here, and this will act the object for the third refracting surface, and it will form an image beyond this third refracting surface as something here, and this will act the object for the preceding refracting surface, and this step will continues, and the final image is formed somewhere here beyond the final refracting surfaces. But this process of taking first image as the object of second surface and second image as the object of third surface and continuing this process is very much tedious one, and now we are going to represent the whole of this translational process by using some matrices and representing these refraction as well as the translational motion of the light ray through some matrices, and it will directly convert the geometrical optical phenomena or translation or a representation of the light ray propagation through the geometrical ways to some mathematical way. Normally we are representing some vectors by using some matrices, some column matrices, like that. Here we are representing the propagation of light ray or the coordinates of light ray in the form of matrices, specifically some column matrices, and obtaining the coordinates of the final position or the coordinates of the image itself. That is the method used here. Here we can divide the propagation of light ray into two processes. One is translation and other is refraction. These two are the process taking place when a light ray propagates through a medium. One, it gets translated through the medium, and the second is the refraction. This is nothing but the direction of this light ray will changes when the medium of the propagation, when the propagating medium changes, when the medium changes. If this light ray is propagating through some homogeneous medium, that means the medium is constant throughout, constant or same throughout the propagation of the light ray, then translation will take place, and if the medium will changes, then the refraction will occur. That means refraction is nothing but the direction of the light ray will changes. So in translatory motion, the direction of light ray is a constant one, while in the process of refraction, the direction is the changing factor. So to represent these translation and refraction processes, we have two different matrices. One is translational matrix for translation, and a refraction matrix for representing the refraction process. Here you may have a doubt that what about the reflection? If you are considering a reflecting surface something like that, it can be a mirror or some other reflecting surface, and a light ray is incident on this reflecting surface, this light ray will definitely get reflected back, and the amount of reflection will depends upon the smoothness of this reflecting surface, and you have these theories, and here is some normal surface and something like that. But in this process of reflection, this medium of the propagation of light ray or propagating medium of the light ray is a constant, and let us consider the value of the refractive index is something mu. This medium throughout the process of reflection, this medium is a constant one, and from this initial position A to the reflecting point O, this light ray occurs a translation process. Similarly, from the point of reflection to the final position B, the light ray will continues in the process of translation. There is no refraction process taking place in this translational behavior of the light ray, and this light ray will continues the process of translation itself. So reflection can be treated as two translation processes, one incident light ray is undergoing a translation and one reflected light ray is also undergoing a translation. So the combined action of two translational process will give the process of reflection. So there is no need of representing this this reflection by using some other matrices, because this reflection can be represented by two translational matrices itself. So we cannot, or there is no need of considering this reflection as some other phenomena, but that it is the translational process itself. So we have to consider this translational matrix or translational process and refraction process in the propagation of light ray through a medium.